Okay, today we are doing an introductory lesson into chapter 2. And the reason we're starting with a lesson that isn't even from the book is because you need some of these concepts in order to do those lessons. And we're assuming you've taken pre-algebra and you know these. But there are some of the concepts that, even though you may have practiced a little bit in 7th grade math, you need a little bit more practice and exposure to it. And just to be reminded of some of the vocabulary and some of the concepts in order to be able to be successful in chapter 2. So some of this you may say, oh, I've got this. I know how to do this. Other stuff, it may be a little bit new or just review. Okay. So let's go ahead and look at this first page. There's no actual work on the first page. It's just vocabulary, some concepts I want you to be reminded of, and some graphs and charts or tables that I want you to take a look at. So up here at the beginning, you have vocabulary. You have slope, you have the M, the B, and then your X and your Y. And I'm going to go through the slope-intercept equation. You need to have this memorized, and you need to know what each variable means within that equation. So the slope-intercept form of an equation is y equals mx plus b, and I know you know that. I know you've heard this before. Within this equation, the m here represents the slope. Slope is also known as the constant of variation, and it is also part of direct variation. So you'll see different letters that the M turns into at certain points. Sometimes it's a K, sometimes it's an A. But for what we're going to be doing in this chapter, slope will be represented by the letter M. Okay. Now, in graphing, you find slope using rise over run. But when you don't have a slope, when you don't have a graph, you need to figure out what is your slope when you only have your X and Y variable. Well, that is the change in Y over change in X. Basically, it's you're taking your the difference between two coordinates of Y and dividing them by two coordinates of X. And that might sound a little bit confusing right now, but as we go further into the lesson, it will make sense. Then you have the B of your equation. This is your y-intercept. And a lot of students will get the y and the b mixed up because the b has y in the description, and then y is also here. But the b part of your equation is where your line on a graph will cross the y-axis. That's why we call the y-intercept. It's where it intercepts the y-axis. Okay. And your ordered pair for it will always be 0 and then some number. Okay. Now, what about the X and the Y? A lot of times we don't even know what those represent. What those represent are your coordinates. So if you think about a graph, if I were to graph or plot a point at 2, -4, 2 would be my X and -4 would be my Y. So it represents the X part of the ordered pair and the Y part of the ordered pair. Okay. Now, one thing I want to make note of before I continue is that when you write slope, slope isn't a number and X. Slope is just that number. So what happens if you have an equation that is Y equals 2X minus 3? Okay. And I ask you for your slope. Well, M is your slope, right? Well, a lot of times that people will say that the slope is 2x. That is not true. Do not write this. Slope is never 2x. The x isn't part of the slope. The x is just what you multiply the slope by to get your y. Or the x is just part of an ordered pair, which is a different part of the equation. Your slope is just 2, okay? So please don't write an X because I will mark points off on homework if you include that X in your slope. Okay, let's go down to different types of slope. Now, this I know, you've watched Slope Dude, you know this stuff. A positive slope always goes up and to the right. A negative slope always goes up and to the left. A zero slope is horizontal. And an undefined slope, I know, I said the bad word in math, undefined, is vertical. And undefined means that there isn't, there's an error in that. There's no answer for an undefined slope. Okay, now down at the bottom, we have two graphics here. We have a graph and we have a table. And these are two representations of slope intercept equations. Let's look at the graph first, the one thing that you're probably most familiar with. Remember that I said that in y equals mx plus b, that your slope, which is 3, can be determined by rise over run. That is why they've taken 2 points, this one and this one, and they've connected them by rising 1, 2, 3 and running 1. So your slope is 3 over 1. Well, 3 over 1 equals 3. And that's what we have right here. Your y-intercept, or b, is 2. That means, if you go back up to the top, it says that's where your line is going to cross your y-axis. And it crosses the y-axis here at 0, 2. Remember, we said that up here, I said the ordered pair is where x is 0 and y is some number. Well, x is 0 and y is 2, and that means that our slope intercept has a 2 at the y-intercept. So y equals 3x plus 2, and that is what this line represents on the graph. Okay, but what about a table? Because we can look at a table like this and we can come up with an equation. All right. The first thing I want you to do is I want to show you how we get slope. Remember up here, I said that slope, another way to get slope is to take your change in y, or difference in y, over your difference in x. That's what's taking place over here, okay? And down here, write a few notes. You have 0, 6, and you have 1, 4. Well, to take your change in y over your change in x, you would say, okay, what is the difference between my y's, my two y's right here? Well, it's 6 minus 4, right? And that equals 2. So my change in y is just the difference between two of my y's. This represents y, this represents x. And then the denominator is my change in x, or my difference between two x's, 0 minus 1, which is negative 1. So my slope here is negative 2, and that's how they got negative 2 here. Okay, but what about the y-intercept? Remember, I'm going to scoot up here again. The y-intercept is when you have an ordered pair where x is 0. So in the table, do we have an ordered pair where x is 0? Yes, we do. Since my x is 0 here, my y is 6, and this is my y-intercept. Okay? That's how we get y equals negative 2x plus 6. So we're going to practice this a bit. Let's go ahead and go to page 2. This first part's going to be a little bit review, okay? So in this first part, we're going to look at the equation here, and we're going to find the slope and the y-intercept. Okay, well here, my slope, and we think y equals m x plus b, where m is our slope and b is our y-intercept. So in this case, 3 is in the slope place. So 3 is our slope, and our y-intercept is 5. Okay. Now I want you to look at the next two, and I want you to try to find the slope and the y-intercept of the next two. So I'm going to give you about 30 seconds to do that, because this is pretty quick. And then I'm going to write the answers on my paper, and when you have written the answers on yours, I want you to check your answer. Go ahead and check your answer if you haven't. I want you to notice here that our slope is a half. Slopes can be fractions. We don't typically see decimals as slopes, so I don't want to see any decimals in your answers, but half is a fraction. And notice that my y-intercept is 7 here, but you have to bring the sign in front of it. This is telling us that the y-intercept, if you look at a graph down here, or a graph right here, these are your positive numbers, positive, and these are your negative numbers. So that's telling us that the y-intercept is going to be graphed at -7 down here. So you have to carry the sign with it. In this one, we see that our slope is a -2, but there is no y-intercept. But there is a y-intercept. We just don't see it. And that y-intercept is 0, which means it's going to go through the origin of our graph. Okay. All right. Now, let's go to identifying equations in slope-intercept form. Now, with these, we are going to rearrange these equations in slope-intercept form. And we've already done that with lesson 1-3, where we did literal equations, but this time there's numbers involved. So our goal is to write our equations in slope-intercept form. That means that we need to get y all by itself, with our slope, our x, and our y-intercept b all on the other side of the equation. So let's look at number 4. We have a y on this side, so we need to move our 2x and our -9 over. Okay. So let me do something really quick. I feel like my screen isn't bright enough. Okay, so I am going to move my 2x over first. It doesn't matter which one you move over first. So I'm going to subtract 2x on both sides. And I end up with 3y minus 9 equals -2x. Now I have to move my 9 over. And I end up with 3y equals -2x plus 9. Now, the key to slope-intercept is that you want your y isolated, meaning you do not want anything with your y, not even the coefficient of 3, which means I need to get rid of this 3. So I'm going to divide everything by a 3. And my equation is y equals -2x plus 9. Did we write this into slope-intercept form? And what this is asking, is this equation in slope-intercept, or is this equation a slope-intercept? It's just saying, are you able to rearrange the equation into a slope-intercept form? And the answer to this is yes, we just did that. Okay. All right. So I want you to look at number 5. I want you to rearrange it into slope-intercept and answer this question. And I'm going to pause the video so you have a minute to do that. And I'm going to write my answer here so you can check it. Okay, so at this point, if you need to pause the video because you haven't finished 5, which I'm assuming you didn't, because I paused it and then unpaused it and no time went by on the video, but go ahead and pause the video and then you can check your work. So this is what I got for my slope-intercept, y equals 2x plus 1. So if you did not get this, I'm going to zoom in just a little bit. I want you to see my work and check to see maybe if you didn't get it correct, what your error was. If you need to pause the video, go ahead. Now we're going to move on to number 6. Anytime you see something that doesn't fit within a slope-intercept equation like this x squared, there's no way you can ever put this in slope-intercept. Okay, so the answer to this one is no. And no, because x squared is not part of slope-intercept. And I'm writing this just in case you come across it somewhere and you need to know why. Let's go ahead and do 7 together, and then I'm gonna have you do 8 on your own. Okay, so we need to get this into slope-intercept form. So I am going to subtract 10x on both sides because I need to isolate this y and get it by itself. So we have 5y plus 15 equals negative 10x. Next, we subtract 15 on both sides. We have 5y equals negative 10x minus 15. Finally, we divide everything by a 5 so that we can get that y all by itself. And when we do this, we end up with y equals negative 2x minus 3. Were we able to get this into slope-intercept? Yes, we were. Okay, I want you to go ahead and do 8 and 9 on your own and then check your answer. So if you need time to do this, go ahead and pause the video because I'm going to keep going. Okay. All right, so I am going to subtract 21x on both sides. And then I'm going to add 42. Oops. 21. And I end up with 7y equals 21x plus 42. And now I'm going to divide everything by 7. And I end up with y equals 3x plus 6. And this is in slope-intercept form. All right, let's look at number 9. There's a square root symbol. So up on 6, it was a squared, x squared. Here's a square root symbol. This is not going to be slope-intercept because slope-intercept does not have square roots. So no. No, because the square root of x is not part of slope-intercept. Okay, let's go ahead and move on to page 3. Page 3, all about graphs, okay? So let's look at some of the instructions here. Writing equations from a graph. You're going to locate the y-intercept, which is B on your graph. This is where the line crosses the y-axis. That's step 1. Step 2, use rise over run to determine your slope m. Make sure you check the increments of your graph. If it goes up by 2s, then you need to count by 2s. If it goes up by 5s, then count by 5s. Also, your x-axis and y-axis may not go by the same increments. So this is very important. So let's go ahead and start this. Oh, step 3, write out your equation once we have that information. So let's look at this. The first step 1 says to locate your y-intercept, which is your B. Our y-intercept is right here. That's your B, and it is on -5. So right here where it says y-intercept, we're going to put a -5. Now we're going to determine slope. So I'm going to take 2 points on my graph, the 2 points they give us, and I am going to count slope. Now I notice my increments are going by 1s on both my x and y axis. So every time I go up a box, I just count by 1s. So my rise is 1, 2, 3. So for my rise, I'm going to write 3. And my run is 1, 2, 3, 4. And so my slope is 3/4. Now, with those 2 pieces of information, I can write out my equation. My equation is y equals m, which is my slope of 3/4, x plus my y-intercept. In this case, it's a -5. So y equals 3/4 x minus 5. Okay, let's look at the next graph. Notice this graph is numbered by 2's, but it's skipping a box. So this is actually going by 1's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it does that the same on all of them. So you're going to look at where it crosses the y-intercept so we can find our b. Well, it crosses at the origin here. So our y-intercept is 0. Excuse me, 0. Now I'm going to use rise over run to find my slope. And you may be saying, but there's no dots on the graph. Well, we can create our dots by finding a place on the graph where the line crosses an intersection. What do I mean by that? Okay, I can always use my origin. And then I'm going to come up here. The line doesn't cross here at an intersection of 4 boxes. It's in the middle, so it looks like it crosses right here. And I go up, and it also crosses right here. Okay, and it also crosses right here. And I could go all the way down and find all of the points where it crosses an intersection. But you only need 2 points. So once you find those 2 points, you could use rise over run to find your slope. So here we're rising 1, 2, 3, and we're running 1. So my slope is 3 over 1, or just 3. My equation, y equals 3x. And I could put plus 0, but I'm not going to because you don't have to. Okay, let's go to graph 12. Graph 12 has no numbers on it. Anytime you come across a graph with no numbers, you will assume that they go by increments of 1. Okay, so this is 1, 2, 3, 4, and 1, 2, 3, 4. Okay. All right, so where does it cross the y-intercept? It crosses right here at 2. So my y-intercept is 2. And you can stop the video at any time and do these on your own if you would like. Next, I need to find another place where it crosses an intersection, and it crosses here or it crosses here. And now I need to find my slope. Now, I know that this is a negative slope because it's going up and to the left. But I'm just going to take one of my points. I'll start here, and I'm going to go down, which is -1, and over, which is 2. So my slope is -1/2. And my equation, y equals -1/2 x plus 2. Now, I know a lot of you are used to, when you have a negative slope, going down and over, but really you can also go up and over. And the reason is because when you have a negative slope, one direction will be negative and the other direction will be positive. So the original one was I went down 1, that's a -1, and I went to the right 2 in the positive direction, so that's a positive 2. But what happens if I start here and I go up? Well, this is a +1, but when I go to the left, I'm going in a negative direction, and that's a -2. So my slope, either way I do it, it's still a -1/2. All right, let's go to 13. 13 is a little tricky just because the line is very thick, but it looks like it crosses the y-axis at 1, 2, 3. So our y-intercept is 3. And then I'm going to use these 2 points they give us, and it looks like they're rising 2 in the positive direction and running 1 in the negative. So that would be a 2 over a -1, which is -2. You could have gone down here. You could have gone down 2 for a -2 and over 1 for a +1. Either one works. And our equation is y equals -2x plus 3. So this is how you can create equations from graphs. Let's look at page 4. Page 4 is graphing an equation. Okay, so I am going to do 3 with you, and then you are going to do 3 on your own. So I'm going to do 14, 17, and 18 with you. All right, so you want to make sure your equation is in slope-intercept form, because if it's not, you have to rearrange it. All the ones on this page, though, are in slope-intercept form, so we don't have to do any rearranging. Step 2, plot your y-intercept. Step 3, use your slope and rise over run to plot 2 to 3 more points on your graph. And step 4, draw your line by connecting your points. Okay, so step 1, we are going to graph our slope, our y-intercept. +3 is our y-intercept. So I'm going to plot a point at +3 on my graph. Okay. My slope is 2. So I'm going to rise 2 and run 1. Okay, so I can go up 2 and over 1 to the right, up 2 and over 1, or I could go down 2 and 1 to the left. Because if I go into negative directions, 2 negatives make a positive. And I can keep going if I want. Okay. Once you get to this point, you're going to draw your line. And yes, I want you to use a ruler. I do not want sloppy lines. So then you're going to create your line, and we just graphed an equation in slope-intercept form. All right, let's go to 15. Our y-intercept is 3. I'm sorry, our y-intercept is -2. So let's plot a point at -2. And our slope is, it says just x, but it's 1x. Anytime we have a 1x, we're going to rise 1, run 1. So we're going to go up 1 over 1, up 1 over 1, up 1 over 1. Okay. And then you can draw your line. Now I'm going to skip. No, I'm going to do 16. Well, yeah, I want to do 16. I'm sorry. Okay, here we go. 16 has a y-intercept of -7. So I'm going to plot a point at -7. And it has a slope of 1/2. That means I'm going to rise 1, run 2. Please do not go up a half of a box. Okay, so I plotted a point at -7. I'm going to rise 1 and I'm going to run 2. Rise 1, run 2. Rise 1, run 2. And this is a positive slope, so I'm going in the positive direction. And I'm going to draw my line with my arrows, and you do have to have the arrows also. Otherwise, that means your line stops, and our line here is not stopping. It's going in both directions infinitely. All right, let's go to 17. I was going to have you do some of these on your own, but every graph is different in some way, and so I want to do all of these. Okay, so here in 17, we don't have a y-intercept. Wrong, we do. It's just 0. So I'm going to plot a point at 0, and then I'm going to graph my slope. Notice my slope is -2. So that is the same as -2 over 1. So I'm going to rise 2, run 1, or go down 2 over 1. So when I rise 2, 1, 2, I just have to make sure I go into a negative direction. One of my negative, so that means I have to go to the left. So up 2 over 1, up 2 over 1. Or from the origin, I could go down 2 into the right 1, down 2 into the right 1. So either way, as long as you're going in the negative direction, then you're graphing a negative slope. Okay, let's look at number 18. I want you to try 18 on your own. I think you can try this. Just make sure that you're doing a negative slope, and that negative slope is a -1 over 1. So you're going to rise 1, run 1. So go ahead and try 18 and 19 on your own. And then, and pause the video, and then you can come back and check your answer, okay? Okay, I'm going to show you 18 and 19, but if you are not ready to see it, pause the video. Okay, here is 18 and 19. They both have to have negative slopes. I know that some of you have the difficulty going up and over with a negative slope because you have not learned it that way. But again, if you have a negative slope, as long as one of the directions you go in is negative and the other is positive, you're going to be graphing correctly. All right, let's go to page 5. Page 5 is just another informational sheet. Let me zoom out of this a little bit, with more of what was on the front, except now what we're going to do is we're going to be focusing on tables. Okay, so I'm going to skip through this because we've gone over it a little bit, and I want to go to page 6. Okay, so page 6 is all about creating equations from a table. So let's look at the steps. Step 1 is to determine your slope by following these steps. Find your change in y. How is y changing at each interval? And find your change in x. How is x changing at each interval? And divide your change in y by your change in x. And we practiced this a little bit on one of the other pages. So let's just do that on the first one, 20. Let's figure out our slope. What you're doing here is you're trying to find out what is the difference between here and here. Well, I have 3 minus 7. Okay, and the difference is a -4. Then you want to find your change in x. What is the difference between here and here? Well, it's 0 minus 1, which is a -1. And -4 divided by -1 is a +4. And that's how we get our slope. Change in y over change in x. So that's our first step. Our next step is to determine your y-intercept by locating what your ordered pair is for x, y when x is 0. Okay, well here x is 0, which means that my y is 3. So 0, 3 gives me a y-intercept of 3. And then we plug those into the slope-intercept equation, and we get y equals 4x plus 3. Okay. All right, what I would like for you to do is try 21 on your own. So please pause the video and try that one. Okay, go ahead and check your answer for 21. All right, now we're going to get down to 22 and 23. I put these in here because they are sideways tables, and sometimes you're going to see those. A lot of times what I do, though, is I recreate the table vertically to make it a little bit easier. And you only really need, oops, see, I've already done it wrong. So we have -2, -10, -1, -7, 0, -4, 1, -1, and 2, 2. Okay. If it's easier for you, do it this way. If it isn't, and you can work with horizontal tables, that's great. Okay, the first thing we need to do is find our change in y over our change in x. So go ahead and do that. And by the way, you don't have to use these numbers. You can use any two numbers within the table, any two y's. So I could do -1 minus 2 if I wanted to. Now be very careful because, oh, I did mess up here. So this is -10 minus a -7, which minus a negative is the same as adding. So I'm going to change that to adding. And then the x is -2 minus a -1, which becomes -2 plus 1. Okay. Remember, I take my subtraction and I add the opposite. And then when I solve this, I get -3 over -1, which is 3. Okay. Now, we have to find the y-intercept when our x is 0. So here I have 0, -4. So my y-intercept is -4. And now I can write out my equation. Okay. All right, I would like for you to go ahead and try 23 on your own. Okay, I'm going to show you the answer to 23, and I want you to check your work. Okay, if I've made any mistakes here, just email me. I think I'm, you know how I am at class. Sometimes I make mistakes, so just email me. We're going to go ahead and move on to 7. We're going to work with more tables, but this time the tables do not show what our y-intercept is with an x of 0. So I'm going to show you how to do that when it's not given in the table. First, though, let's go ahead and find our slope. We take 10 minus 4 and -3 minus a -1, which becomes -3 plus 1. So 10 minus 4 is 6. -3 minus a -1 is a -2. 6 divided by -2 is a -3. So we have our the start of our equation. We know that it is going to be y equals -3x something, right? Okay. Now, we do not have a 0 in our x. So what we're going to do is we are going to determine our y-intercept by using the slope-intercept equation, y equals mx plus b. And we are going to substitute an ordered pair, an x and a y, and we get to choose whichever one we want over here, an x and a y, and the slope that we got, so that we can solve for b. Now, if that sounds confusing, just watch what I'm doing right now. Just watch, don't write, and then go back and fill it in. So I am going to take this ordered pair right here. Now, I could take any ordered pair I want, but because those are smaller numbers, I want to do that. 1 is my x, -2 is my y. And then, so I'm going to plug 1 where the x is, -2 where the y is, and then my slope of -3, I'm going to plug that in. So what is that going to look like? Well, y here is -2. My slope is -3. And remember, we multiply m and x. And my x is 1, so I'm going to multiply that by 1. And we don't know what our y-intercept is, so it's plus b. We're trying to figure out our y-intercept. So with this information, we have enough information to solve this to figure out what b is. So the first thing I have to do is I have to figure out what is -3 times 1, which is -3. And we have to isolate that b, get it by itself so we know what it is. So I have to add 3 to both sides so I can get b by itself. And -2 plus 3 is 1. b equals 1. That is my y-intercept. Plus 1. Okay? So all we're doing is we're taking our slope-intercept equation, we're plugging in all the information we know, and that means we're plugging in an ordered pair for x and y and our slope, and we're solving for b. Okay, let's try 25. Okay, so we're going to find our change in y over our change in x. And so we have 3 minus 1, no, I'm sorry, 3 minus 11 for our change in y. And that gives us a -9, no, a -8, oops, sorry. And then we have our change in x, which is 1 minus 3. And that gives us a -2. -8 divided by -2 is 4. Okay. So we have our slope, and now we need to choose an ordered pair. I'm going to choose 1, 3. Okay. So let's write out our blank equation, y equals mx plus b. And let's substitute in everything that we know. Since I'm choosing the 1, 3 ordered pair, 3 is my y. My slope is 4. I'm going to multiply that by my x of 1. And then we don't know what b is. So now let's solve for b. So 3 equals 4 times 1 is 4. Now we're going to subtract 4 on both sides. And 3 minus 4 is a negative 1. So our y-intercept is a negative 1. So up here, we can write 0, negative 1, which gives us negative 1. I didn't do that on the first one up here. It was 0, 1. Okay. So now let's write our equation. Y equals 4x minus 1. Okay, I would like for you to try 26 on your own. Just give it a shot and let's see what you come up with. Pause the video and then you can come back and check your answer when you're done. Okay, if you're ready, I'm going to put up 26 and you can check your answer. This one was a little bit tricky. We had a fraction and our y-intercept ended up being 0. So if you did not get this, I want you to pause it and I want you to look at my work and just see what how I did this. One thing I do want to help with is that 1/2 times 2 is just 1. So that's how I came up with the 1 here. All right, we're going to go to the final page. These are word problems involving slope-intercept. It's a little bit easier than what you think. So when you're dealing with word problems, you always want to figure out which part of the problem is changing because that's going to be your slope. Okay. And then you determine which part of the problem is not changing. This is going to be your y-intercept. It's the thing that you start with or the thing that remains the same. So I use rate of change with word problems. It's the same as slope. Okay, but with real world situations, we call that rate of change. So let's look at our problem. The cost for a batch of cookies from Tiff's Treats is $10. Okay, so 10 plus $5 for delivery. So $5 for delivery. So per batch of cookies is $10. So in looking at this, my $10 is going to, or my number of batches is constantly going to change, right? The $10 will change based on the number of batches. And my $5 delivery fee is a one-time fee. That's a one-time thing. It's not changing. It's where we start. So our flat rate is the $5. And what is changing is the $10 based on the number of batches. And so this is 10. And we would write our equation out as y equals 10x plus 5. And you could read this as each batch of cookies costs $10. And then I have to tack on $5 for delivery. So say I bought 2 batches. 10 times 2 is 20 plus the $5 delivery fee would be $25. And that's how much it would be for 2 batches of cookies to be delivered by Tiff's Treats. All right, let's go to 28. The cost for a new desk for our classroom is $100 plus $25 for delivering the entire order. How much would it cost for a certain number of desks? So we don't know the number of desks, but we do know that it's 100 per desk. So that's what's going to change. Our 100 will keep going up depending on the number of desks. So our rate of change is 100. And we have a one-time delivery fee of 25. So that's our y-intercept. And so our equation is y equals 100x plus 25. Light started to dim. Okay, I would like for you to try 29 and 30 on your own. And then we'll come back and check it. So go ahead and pause the video. Okay, I'm going to go ahead and show you the answers to 29 and 30. If you're not ready, pause the video. Okay. So the slope is 150 because it depends on the number of nights you stay, but the cleaning deposit is a one-time flat rate. And then for Six Flags, you don't know how many tickets you're going to buy, so that would be 60x. But you know that in order to park there, it's going to cost you 25 one-time fee. Okay, let's look at 31. I have $150 in my bank account, and every month $25 is deducted for my cell phone bill. How much is left in my account after a certain number of months? So you're starting with 150. Okay. And so that's your flat rate that you're starting with, 150. And every month, $25 is being deducted. Now, deducted means that that's going to be a negative slope. So $25 is being deducted every month. So the way that you would write this one is y equals negative 25x plus 150. Because you're taking that 150 and you're subtracting $25 every month. Okay. All right, let's look at 32. I have $250 in my savings account. Every month I deposit, that's addition, an additional $50. How much is left in my savings account after a certain number of months? I think you could probably do this one on your own. So go ahead and do this one. And then when you're finished, check up here for the answer. Okay. Okay, this one is a positive because you're adding to your account every month, whereas this one you were deducting. Okay, so that includes the notes for our introductory lesson to chapter 2, lesson 2-0. And if you have any questions, email me. And make sure that you're checking your notes as you do your homework in case you have any questions.